Today we are going to review the homework 5. There are 5 questions and we can start with, are these two variables the same? Okay. This question is exactly same with this one, Module 4, this question. Okay. Only difference is we are implementing this operation without using the loop statement. Okay, so we copy this code, then so how to find out that these two vectors are same or not, we can just directly use this equality operator and back. Okay, and then if it is the same, all value in this output vector, output logical vectors are 1, so we simply use the all command, all built-in function. Okay. We can solve the B in a similar way. How to compare this to two character vector? It's the same, right? All character vector 1 is equality character vector 2. Okay. So please compare this solution with the solution with the loop structure, loop and if statement structure that were used in this module 4. Okay. You can extremely shorten all this script by introducing this operator. Okay, so run this, no error. We copy this solution to here, no error, submit. Okay, good. So next question is the value replacement using the array operation. So this one is also exactly same with the one in the module 4. So if you see the module 4 value replacement using the loop. Okay. So this. Please compare this solution with this new solution. Okay. How? Let's say store value replacement. Okay. Copy the given code. So vector 1 is larger than, we can use this relation operator between the vectors and scalar. So larger than 0 and vector 1 is less than 50. Okay, that is the index, right? So logical index logical A. Okay, makes sense. And then how to change the value? Index, logical index, and use the logical vector as a logical indexing. Okay, and that is replace it to. How to change the rest of the value? So we already covered this topic right here. Vector. Okay, not this one. Yeah, this one. If you put not, you can assign the value in the rest of the other place. Okay, so far. Okay, makes sense. B is you can play with the matrix, but the logic is exactly same. The B can change this one is the mat 1 and mat 2. We can use the logical matrix as a logical indexing, right? Like this. And change this one. Okay? Does it make sense? Okay. Let's store. Logical is a vector. Okay, vector 1. Let me print. Oh, it's too long. Okay, but anyway, so this is the way of the logical. Use the logical vector as a logical indexing. Okay, please compare this solution with your solution for module 4. Okay, so this is my solution, but compare with this two. Okay, this solution is much more readable and then straightforward. Okay. This one is the factorization. Rather than read the individual value from a vector, you can directly compute the value using the vector and filtering function. Okay, run it, no error. Copy this solution here. Run script, no error. Submit. Okay, good. Next question is candy store. We like the candy store, right? This one is also the same with very similar to previous question, previous candy store question. So let's copy this code. Okay, this question is prize is awarded to all customers who qualify. Okay, and then condition is this one. 3 appears the third and fifth indexes and the card number. Okay. So here, all the card numbers store the card number all. Okay. How to do this operation using the array rather than the accessing the individual card number. Okay. Let's evaluating this condition first. Card number is the 3000 by 10, right? So third indexes is the third column, right? Card number all third column equal to 3, and card number all fifth indexes equal to 3. Condition matrix. Okay. In this case, not condition matrix, condition vector. Okay. So what value inside of the condition vector? Okay. What does it mean by the 1 in this condition vector? That is the location where card numbers satisfy this condition, these two conditions. Does it make sense? Okay, here card number all is the 3000 by 10, right? So this code is the third column, fifth column, right? Okay. So this card number all, this one give you the one location is the satisfy this condition. 0 is the not satisfied with this condition, right? So we are looking for the column number that satisfies this both condition. That's why your script looks like this one. Okay. Then this question is asking you how to find out the number of the price of receiver. Price receiver. So just simply summing up all 1. This is a condition vector. Okay, that's it. That's so simple, right? You know, this is the beauty of the vectorization. Without accessing the individual element, individual row vector, in this case, row vector or the column vector, we can directly do the operation with an array. Okay? Store homework 5 can be stored. Okay, run it. No header. 31 price receiver. Good. Run script. No header. Submit. Okay, good. Okay, next question is a building sensor installation. This one is a tricky problem. Okay. Let's review this problem first. First, the data is the N1 by N2 matrix. Each data point represents the force acting on the face of the building, right? And then the goal of this problem is to find the 5 sensor locations, and they should be consecutively placed in a row or column direction. Okay. The sensor location determined by whatever 5 consecutive points that have the highest average force. Okay. This problem is almost the same with the word find puzzle. Word find puzzle is to find out the banana, but this one is to find out the highest average force. Okay. So let's store this building sensor. Okay. Then copy this given code. And then let's open the word find puzzle. Where's the word find? Okay. So take a look at so let me maximize this window. Okay. So let me review this one again. This one is wrong. So here we make the I is equal to 1 to puzzle size. Okay. And then this one is a puzzle, is I is a column, and then row, accessing the row. And then this one is the test location, right? And then we are going to test, to see if this, the value inside of the puzzle has a banana or not, right? Make sense? This one is the same. Okay. This one is, but the difference is in this example, column and then row vector. So here, column and a row, column vector and row vector has the same size, right? But in this case, N1 by N2. This means that they're the different size. We are going to make a separate loop structure. Oh, this one is wrong. Okay. The first data is a given. So we first make a range is a 1. II is okay. Here's the thing. What is the output? Output is the sensor location, right? Sensor location, we first define initialize sensor location is the 5 by 2, right? And then here define the max average. Max average is equal to 0. Okay. And then make a loop structures. II is equal to 1 to the. Let's find out the row, each row. Let's compute this sensor location in the row location. Then we set the range is II is equal to 1 to N1. And then for JJ is equal to 1 2. How to design this one? And 2 minus what is the sensor? How many sensor place? 5 plus 1. Okay. Does it make sense? Okay. And then test location is the JJ to JJ plus 5 minus 1. Okay. So this one is exactly same with this part. Okay. Okay. And then read a value. How force data II's row and then test the location. That is the testing force data. Test the force. Okay. Okay. Then this is the tricky part, but we already learned about this one. How to find out the maximum value? F max average. Okay. So mean test the force larger than the max average. You're going to assign the max average is the mean test the force. I mean, this one is not good code. Okay. What about this one? We pre-compute the test the force here. And then here test the mean. Okay. And here you're assigned the test the mean, and we are going to assign the sensor location. Okay, what is the first column? First column is a row location. Row is the II, right? Sensor location. Second column is the test location, right? Does it make sense? It's exactly same. The only difference is a condition statement. This one is a condition, is to check if the testing value is the banana or not. But this case is the testing value is the so larger than the current maximum value. Okay. In the end, think about if you this loop structure is repeating, and then finally this max average is the maximum value on this 5 consecutive sensor location that is placed in the row direction. Okay. Does it make sense? Okay. Let's continue to this. This one is the row, right? Direction. And then we are also evaluating the column direction. Column direction. For II is equal to 1, 2, and 2, right? And then JJ is equal to 1, 2, and 1 minus 5 plus 1, right? So that's why this range of the loop range is different from the column loop range is different from the row loop range. That's why I cannot merge this this two in a single loop. Okay. And we still use this maximum average here, right? We should not initialize this maximum average. Can still continue. Okay, we copy this code here. Okay, and then sensor location is the same. A test location is the same. The forced data is the test location at the JJ's ith column, right? Makes sense? And then test min is a maximum average. Max average is set to the test min. And then sensor location is this first column should be the test location, right? This one. Oh, this one is row. This one is a column, right? Column. This should be Okay. That's it. The key part is use the this idea. Okay. Find out the maximum number. Once you find out the maximum number, you assign this sensor location. Okay. The way of the compute this task number and the sensor location is from the word find a puzzle problem. Okay, makes sense. Okay, let's run it. Okay, no error. Okay, then copy. Okay, copy this code to here. I think this one is wrong. So let me refresh this. I just deleted that text line. Yeah, here. Copy this code and then run it. No error. Submit. Okay, good. Okay. This is a very cool question because you merging these two ideas, one from the word find puzzle, one from the implementation of the max function, max built-in function. Okay. The tricky part is you're designing this max average for both the row and column. Okay. So maybe if it's not easy to design these types of code, you can find out the maximum value from the row and the sensor location, the maximum value from the column and it's the sensor location. Then later you compare these two. Okay, max from the row, max from the column. The max from the row is higher than the max from the column. You can assign the sensor location from the row. Okay? Make sense? Okay, good. Co-op decision. This one is another tricky problem. Okay. 5 co-op decision. Okay. Then copy this given code. Okay. And then the co-op factor is a 7 by 6 matrix. with each row corresponding to a different employer, and then each column being a different factor: salary, daily commute, the living cost, the quality of the experience, previous students' rating of the job, and then DH is the distance from hometown. Okay, so A is the DH300. Determine the what employer number you should work for if you work within the if you want to work within a 300 kilometers of your hometown. What employer numbers, right? Okay, so your first DH factor, co-op factor, what is the data? That is the last row, right? So let's put the number here, 1 to 6, right? And then how to find this number? You can H300. So find DH factors less than 300. Okay? Or you can split this code in the two line. Like load Z 300 is a DH factor less than 300, and then use the load Z factor inside of the find. Okay, B is the determine the best employer. Okay, how to find out the best employer? So the employer numbers, if you employee that is the best in the most factor. Okay. Then the tricky part is the good factor. So high salary is the better, but daily commute is the lowest the better. Lower better, right? Living cost the lowest the better. Quality of the experience higher better. Previous students rating job higher better. Distance from the hometown is the lower better. The lowest the value is the better. Okay? So to solve this problem, you can design the loop structure, but in the model answer, I tried to solve the using the vectorized code. Okay. First, I found out all the ID for the max co-op when the maximum is better. This one is all the max ID for co-op factor. So if you run this, okay, so let me complete this one first. Okay. What this mean? This mean this one is a co-op factor here. Oh, no. Co-op factor is the 6 by 7, right? The 6, 7 employer in the 6 factor, right? This one is a co-op factor. Okay. If you do max co-op factor, that is, you're finding out the maximum number of each column in the vertical direction, because default direction is a vertical. So this ID is the location where the maximum number is. Okay, Okay. Basically, this one is the employer number. Employer number for each category. Okay. And then minimum is the same. Minimum is the pick up the lowest, the employer where has the lowest number, right? Okay. But in this case, the best employer is to pick by considering this factor, right? Good factor, higher factor, the consider this a high and low and good factor. The best employer should be determined based on the higher good factor, right? High factor or as a high or low, right? So here we only consider this a high ID is the salary and quality of the experience and previous student rating, right? That's the good factor, right? This one is we pick a employer number that corresponding to this factor, this a high factor. The factor that high value is the better, right? Okay. And then low ID is the rest of one. That is the second, third, and sixth, right? Okay. But here, to pick the best employer, the employer that is the best in the most factor. Okay. The hint is to use the mod function. Let's take a look at the mod function. Mod function is most frequent value. Okay. Makes sense? So if the employer who is leading the most of this factor, that employer is the best employer. So to use the mod function, simply make the array like this. That is the best employer. Okay, so maybe I split this line. Best factors, best factor, employ is this matrix. This is a 1/6 matrix. And then we can place this best factor. Okay. Let me debug this code first. Okay. Let's print out. Okay. Let me first fix a random number so that we are using the one number, one this a core factor. Okay. Print out this one. Okay. What is the core factor? Factor is here, right? Then I copy this array. Okay. Okay. Okay, let me. Okay, this one. Okay. Okay. Here the highest value is 22. This one is a game, but this max function is the pick up maximum value at the first appearance, right? 85, 7. Oh no, not this. 800, 10, 10, This one, right? So 1, 5, 6, 3, 1, 4, right? Let's check this value. High ID, so 1, 5, 6, 3, 1, 4, right? Makes sense? Okay, and then check the lowest number. Lowest number is the where is it? 12, right? Then 0, 100, 1, 1, this one, right? So 2, 6, 1, 1, 2, 3, right? Let's check this value. Low ID is 2, 6, 1, 1, 2, 3, right? Make sense? Okay. The best employer, okay. In this case, the best okay. So let me, okay. As salary, TC, LC, living cost. Okay, no. In the lowest case, only these values are meaningful. This one, this one, this one. Oh, no. This one, and living cost, right? Okay. So minimum values of this daily commute, the living cost, and then distance from the hometown is also the meaningful value, right? So we take only that value. That is the second, third, and sixth, right? And then high value is the salary, quality of the experience, and the previous student's rate. So 1, 4, 5, right? So best employer factor become some kind of matrix, right? And no, it's a vector, right? And then this, okay, it's a best factor. Oh, best factor employee is the, what this mean? Let's take a look at this one. What is the 1 means? This the first employer. This value is the best one. Okay, this value is the best one. That's why this first employer, this 1 is assigned to here. What about the daily commute? Lowest one is the best one. So that is the fifth one, the third one. That's why 3 is assigned here. Living cost, the lowest the better, right? Lowest the better. Okay. So lowest the better. Lowest the better, right? That is the first one. Okay. Do you get this point? The best, what is the best factor employer? Then the question is asking you, so employer that is the best in the most factor. Then we can use this mode function. Okay. Then best employer become a 1. Okay. C is the, so live 500 is the determine what maximum salary that you receive while you paying the less than 500 living cost. Okay. We are going to accessing the salary that satisfy this condition, right? So we first find out the logical vector. Okay, so let me So access the living cost factor, that is the co-op factors at what location? Living cost, the third one, right? Third one. Okay. So LC factor, you're going to find out the index of the valid salary. So that is valid index ID of the salary is the LC factors less than 500, right? 500. Find. Okay. Make sense? Okay, then your salary valid is the co-op factor where ID salary. Salary is the index of this living cost less than 500. That is the first column, right? Salary is the first column. Okay. So this value is the max salary value. Okay. This is the solution that we use to find built-in function. We can solve this problem without using this find the built-in function. Okay, so salary is the LC factor. Okay, less than 500. Because then salary factor is the co-op factor, the first column, right? Then salary factor lossy salary, right? This one is the salary valid. Okay. Then live 500 is the max salary value. Okay. You can write a script like this. Does it make sense? Okay. Good. What about the D? D is the average salary which determines the salary of the employee whose previous student rate is greater than or equal to 7. Okay. This one is similar to the C, right? Okay, student rate, okay, what is the student rate is the previous rate, PSR, right? PSR factor is the co-op that is the 1, 2, 3, 4, 5, right? 5. Okay. And then PSR factor so greater than or equal to 7. There's the lossy PSR, right? Okay. Then average salary valid is the Okay, so salary factor is the co-op factor. Co-factor is the first one, right? And then salary so average salary is the mean salary factor, so lossy PSR. Okay, makes sense. The structure is the same with the C. Okay, so then you copy this solution. Oh, first you run it. Okay, there's an error here. Where's the 40 factors, right? Factors. Run it, no error. So you copy this code, paste here, run it, no error, submit. Okay, good. So in this homework, the building sensor installation and the co-op decisions are a little bit tricky. Okay, good. Then see you next time. Bye.